This is the final review graphing portion. It's the end of your final review. We're going to start with problem number 66. And we're going to be graphing f of x equals the square root of x plus 2. So I'm going to draw a graph. Since this is shifted up 2 places, I'm going to start at 2 on my y-axis. The slope in general is 1. So I'm going to go up 1 over 1. And then you have to remember what the shape of this is. And the square root of x function looks like looks like this, sort of. That's not a very good one. Hold on a second. Okay, so it looks kind of like this. Can't get my graph to go. There we go. That's kind of what it looks like. So, since our graph is that same graph, it's just shifted up 2 places, we're going to go right through here, and that's our graph for number 66. For number 67, f of x is the negative square root of x minus 2 plus 3. So this is going to be reflected, shifted right 2 places and up 3 places. So right 2, up 3. Okay, so on my graph, I'm going to start out right 2 and up 3, so I'm going to have a dot at 2, 3. And this time the slope is negative 1, so I'm going to go down 1 over 1 for my first dot. And then I'm going to make the same general motion, which is just like this. Okay, number 68. F of x is 1/2 the square root of x minus 3. The 1/2 tells us that our slope is going to be up 1 over 2, so this is going to be a shrink. And the x minus 3 tells me to shift right 3 places. So I'm going to start at 0, 0, and I'm going to put my first dot at 3 places to the right. And then the slope is going to be basically up 1/2 and over 1. So it's as if we had 1/2 over 1. So up 1/2 and over 1, so that shrinks it down here. It's really close to being up 1 over 2. So if you did that, that would be okay because they're very, very close. So, all right. Number 69. We're going to take negative 2 to the x as our graph. For this one, when we did these types of graphs, I made an XY table so that I would know where to put my numbers. So what we're going to do is we're going to pick a couple of x values that are useful, like 0 and 1 and negative 1. So if you plug in to this equation, when x is 0, you get negative 2 to the 0 power, and negative 2 to the 0 power is going to be 1. If I take x is 1 and plug it into this equation over here, I get negative 2 to the first power, which is negative 2. And if I plug in negative 1 for x in this equation, I'm going to have a negative 2 to the negative 1 power, and that means it's going to be flipped over and be negative 1/2. You can also graph this in your calculator and look at your table on your calculator to get these points to help you graph it better. So for us, we have 0, 1. We have 1, negative 2. And we have negative 1. I did something wrong. Oops. My 0 should be negative 1. Sorry. So back up. Let me back up my dots. Okay. Should be at 0, negative 1. 1, negative 2. And at negative 1, it would be negative 1/2. Okay. So, it's actually going to look like this. In the calculator, if you were to put this, it's going to be like this. Y equals, you're going to want to put parentheses. No, I take that back. You're going to want to make sure that your negative is outside the parenthesis. If you don't put your negative on the outside of the parenthesis, it will give you the wrong graph. That's why I messed this up, was because it should be negative. Okay? Number 70 is going to be similar to that. Again, you can use your calculator. You have f of x equals 3 to the x minus 2 power, and then plus 1. So, again, I'm going to make a table of values, and I like to use those same 3 values because they're easy numbers to plug in. So if we start with 0 and plug 0 in for x, and I may regret this for this one. Actually, let's pick some different numbers. Let's pick 2 and negative 1, and how about 3? Now the reason I'm picking these numbers is because I'm looking at my x minus 2 part up here, and I'm looking for what numbers would be good numbers to put in there to give me 0, to give me 1, and to give me possibly negative 1. So if I plug in 2, this will be 3 to the 0 power plus 1. 3 to the 0 power is 1, and 1 plus 1 will be 2. If I use negative 1, then I'll have 3 to the negative 3rd power. That's probably a bad one to use, but we'll use it anyway. If I use 3 to the negative 1 minus 2, that'd be negative 3. So that's going to be basically 1 point, let's see, 1 over 27, 1.01. We'll do it like that. That was a bad choice. If I plug in 3, though, up here, then I'm going to have 3 to the 1st power, which is just 3, plus 1, which is going to be 4. Okay, so let's see if I got close enough with my numbers. If I do 2, 2, and if I do negative 1, it's just above 1. Yep, that'll work for us. And 3 is going to be at 4. Okay, so I almost messed it up really badly, but it turned out to be okay. And again, in your calculator, you would do y equals 3 to the x minus 2 power plus 1. Okay, number 71. All right, so for number 71, let's take one off. I've got log base 4 of x plus 1. Now let me tell you, before we start making our table and doing this by hand, if you use your calculator for this, you would do y equals log x divided by log 4. That's the way you put it in the calculator. Now if you're going to do it by hand, which I'm going to attempt to do it by hand, then I'm still going to make a table, but this is going to be a lot easier if I don't have to deal with the logarithm. So what I'm going to do is I'm going to rewrite this up here to where the logarithm's not part of it. So, let's see. That's going to be y equals log base 4x plus 1 plus 1. Oops. That's really hard to see. Plus 1. Let's see. Hopefully you've written this all down for the calculator part, because I'm going to erase it. I use the space. Okay, so if I write it as y equals log base 4x plus 1, then what I'm going to do basically is just do y minus 1. So what I'm doing is I'm subtracting the 1 from both sides. So that gives me y minus 1 equals log base 4 of x. And then I'm going to rewrite this. So I'm going to do 4 to the y minus 1 power equals x. So 4 to the y minus 1 power equals x. So when I'm picking my values over here for my chart, I'm going to pick y values that will be useful, and then we'll get the x value based off of that. So if I used a y value such as 1, then when I plug it into this equation right here, I would have 4 to the 1 minus 1 power. So that's 4 to the 0 power, and 4 to the 0 power is going to be 1. So the x value when y is 1 is going to be 1 also. And then I would also use 2. So 4 to the 2 minus 1 power, so 4 to the first power is 4. And let's use, how about 0? If we plugged in 0, this would be over here 4 to the 0 minus 1 power, so that'd be 4 to the negative 1 power. 4 to the negative 1 power is the same thing as 1/4. So I'm going to plot these 3 points. I'm going to do 1, 1, 4, 2, which is going to be right there inside my, and then 1/4, 0 is right there. Now for a logarithm you have to remember, or it's useful to remember, that it does not cross the y-axis. So it looks a lot like the square root function, except for it continues to go straight down. Okay, so I'm going to use the exact same thing for 72, exact same process. So first of all, f of x is equal to log base 2 of x plus 1 minus 2. And if you're going to put this in the calculator, you would do y equals log x plus 1 divided by log 2 minus 2. But for our purposes, I'm going to rewrite this. So from the top up here, I'm just going to write it as y equals log base 2 x plus 1 minus 2. And now I'm going to change that equation to get rid of the logarithm. So I'm going to add 2 here, and I'm going to add 2 here. So that gives me y plus 2 equals log base 2 of x plus 1. And now I'm going to rewrite it. 2 to the y plus 2 power is going to equal x plus 1. So this one's not going to be quite as pretty as the last one. So I'm going to have 2 to the y plus 2 power equals x plus 1. Of course, that's right in the middle of the symbol. And I'm going to rewrite this on the next screen before we graph it. So 2 to the y plus 2 equals x plus 1. 2 to the y plus 2 equals x plus 1. If you use the calculator form, I'm going to go back and show this. If you use the calculator form right here, you can use your table to get your values, but you can also graph it on your calculator to see what the shape looks like. So just keep in mind that you can always use your calculator. Alright, so when I do my XY table here, I'm going to pick Y values to plug in. So I'm going to pick my Y value to be -2, because if I plug in -2 for Y, that would give me 2 to the 0 power equals x plus 1. 2 to the 0 power 2 to the 0 power is 1. If I subtract 1 from both sides, then that'll give me 0. And then the next one I'm going to try is when y is -3. If y is -3, then I would have 2 to the -1 power equals x plus 1. 2 to the -1 half, 2 to the -1 power is 1. Let me try that again. 2 to the -1 power is 1/2. If I subtract 1 from both sides, then I have 1/2 minus 1, which is -1/2. And let's see, what else can we plug in that would work? How about -1? If we plug in -1, plug in -1 for y, then 2, just messing up everywhere. Then 2 to the -1 plus 2 power, that'd be 2 to the first, equals x plus 1. So that would give us an x value of 1. Okay, so 0, -2. -1/2 is at -3. And 1 is at -1. So then this is going to take that same general shape, but remember it also goes back this way. Probably those are the hardest ones to graph, 69 through 72. And that's what your calculator is useful for, and it can definitely help you with those. Okay, now to some of the easier graphs that we did not too long ago. We're going to graph a circle, we're going to graph a hyperbola, and we're going to graph a parabola. So for number 73, we have a circle. The equation here is x squared plus y squared equals 36. So if 36 is r squared, then that tells me my radius is just going to be 6. So there's no shifting with the x and the y. So I'm just going to start at the origin. That's probably not a good spot. Start at the origin for my center, and I'm going to go 6 units in every direction. So 6, 6, 6, and off the page will be my last one. That was not a good choice. But I would connect this and make a circle if it had gone a little bit better. So this down here would be way down there at -6. That's my circle. One of the easiest ways to know that it's a circle is because it has a radius. All right, number 74. I have an ellipse. It's addition, and it's equal to 1, so that's how we know it's an ellipse. So with an ellipse, the larger denominator is going to be a squared, and so the smaller denominator will be b squared. So for the purposes of graphing, I know that a is going to be 3, and I know that b is going to be 2. So I'm going to go ahead and start the graph, and then we'll come back and find c. So this is x squared and this is y squared, so this is going to be at 0, 0 for our center. Center is at 0, 0. And a squared is under x squared, so that tells me the 3 is going to go in the x direction. So from the center, I'm going to go 3 to the right and 3 to the left. And from the center, I'm going to go 2 up and 2 down. Connect these in an oval shape, and that tells me, or that shows me my ellipse. Now, since it's an ellipse, to find c, we use a c squared formula that is a squared minus b squared. So c squared would be 9 minus 4. So c squared would be 5, so c would be the square root of 5. We've done this a couple times. It's about 2.2, I think. So on your graph, the c is going to be right here and right here. And for the purposes of saying the points for your foci, you're going to have 2.2 comma 0 and negative 2.2 comma 0. And there's c. Okay, one more graph. We're going to graph a parabola. I know that it's a parabola because it has x squared, but it does not have y squared. So if you only have one squared variable, then it's going to be a parabola. To be able to graph this parabola, first of all, it has to be in the proper format. And for a parabola, the squared variable has to be by itself. So this one is not by itself, which means I'm going to multiply both sides by 4 because the reciprocal of 1/4 is going to be 4. So multiply both sides by 4. Then the next thing I do is I take this number in front of y, and I know that it's going to be 4p. So for this equation, 4p equals 4. And if I divide both sides by 4, then I get p is 1. And on your review paper it says c, but it should be a p. And on the test it will say p. Alright, so I'm going to go ahead and graph it, and then I can tell what the focus is and what the directrix is. So this does start at 0, 0. The p is 1. And since this is x squared either goes up or down. And since p is positive, it's going to go up. So we're going to go up 1 unit from the center. And then I'm going to double this number. So 1 times 2 would be 2. And I'm going to go 2 to the right and 2 from the left. Now notice that's right in line with the focus dot. So when I graph this, the focus is the part that does not get graphed. It's just there in the center. So going to graph my parabola around that. But now I can see that my focus is at 0, 1, sorry, which means my directrix is going to be at -1 right down here. So y equals -1 will be the directrix. So let's see, we said it opens up, and then we also point out our vertex is at 0, 0. So those are all the things that you'll have to know about the parabola.